out of it. And as I usually say on Monday, you still got today and tomorrow, but spend some time with the people that are around you and in your classes and network, because chances are there's going to be somebody in this room that either has the same problem, has solved the same problem you're trying to go after. So it's not just about the classroom education, it's about what you can get out of the entire event. So I hope you've enjoyed the conference. We thank you for attending, and you get the most out of the last couple days. So with that, I'm going to introduce this morning's keynote speaker, Tony Rathburn. Tony is a senior consultant and director of training at the modeling agency, and also the director of Laptop Analytics, a predictive analytics training newsletter. He holds an exceptionally strong track record of innovation and creativity in the adoption of predictive analytics in business environments. Tony has assisted commercial and government clients internationally in the development and implementation of applied analytics solutions since the mid-1980s. Tony supports clients on 5 continents, delivering custom workshops, mentoring organizational adoption and individual project design, and consulting on a wide range of commercial and government assignments. He is a regular presenter of the data mining and predictive analytics tracks at TDWI, as well as being engaged in with a number of software vendors to present practical implementation aspects of their tools. Tony's academic training includes 7 years of teaching MIS and statistics at both the graduate and undergraduate level, while an instructor at the College of Business at Kent State University. Prior to entering consulting, Tony served as the Vice President of Applied Technologies for Neuralware, a neural network tools and consulting company. He also is research coordinator for Lakeshore Trading, a successful future and options trading firm on the Chicago Board of Trade. So with that, I give you Tony Rathburn.
Thank you, Paul. Thank you for all of you that are here today. It's nice to be back in Boston. I don't get here as often as I'd like. This morning, we want to take a little time and talk about analytics. And I want to talk about it in a little different format than what we're used to doing. A lot of people today, there's a lot of buzz about how to make analytics work. How do we deliver value into our business organizations? And it's been getting a lot of attention over the last few years. But realistically, if you really go back and think about it, this is an area that we've been focusing on for 50 years now. Going back to basic stats programs in the 60s, and how do we use our data, and how do we use these quantitative techniques and actually enhance our decision-making processes. And it's been a challenging development effort. We've walked through the whole idea of applying quantitative methods, whether it's in statistics, decision support systems, data mining, knowledge discovery, predictive analytics, big data analytics. We go through these development cycles, and it's this perpetual effort. We understand the potential, and we struggle trying to figure out how to actually make this work well. And I think it's largely because of the way we think about the problems. There are at least 3 perspectives, and I think 3 major perspectives on how we deal with analytics and how we approach these topics. There's the quantitative perspectives, the raw math, and all of the techniques. And in many of today's organizations, we've assembled exceptional talent pools, people who are quantitatively gifted. If there are any of you in the room, please, show of hands. Is there anybody who dreams in calculus? Yeah. There are people who do that. I'm not one of them, okay? But they're interesting to work with and talk to, and they're a little scary at times. But we've got people with these skill sets that are amazing. And over the last decade or so, we've started developing this idea of predictive analytics. And we've understood that it's not enough just to do the math. What we need are the data resources to go with it, to apply. And in today's environment, especially with the conversation around big data and the social media aspects and the rapidly growing pool of data, I saw a number the other day that I found extremely interesting. The data that's being processed by a community, small neighborhood, 20 families, is roughly the equivalent of the entire data processing capabilities and data collection efforts of the internet in 2008. Okay? Think about that for a minute, how much the data is expanding. We need to organize that. We need to collect it and organize it and cleanse it and maintain data quality and worry about all the data issues and deliver it appropriately. We've got a huge challenge in dealing with the data. But why are we doing this work? Why are we concerned with the math? Why are we concerned with collecting this data? For the most part, we're not research centers. Those of you that are in an academic environment, fine, but most of us are in a business or governmental unit. And we're not really concerned about advancing the theory or the state of technology and the state of the art. And we're not concerned with building these large libraries, the equivalent of a major university library of data. What we need is to deliver business value. The business objectives are what we're concerned with. How do we enhance business? How do we meet our objectives more effectively? Our objectives are defined and evaluated based on our performance metrics, our KPIs. What are we doing with this data? What are we doing with our technology that truly delivers value to the organizations and gives us a return on investment for these major expenditures that have been made over the last decade or so? Businesses are different than a lot of the quantitative methods, approaches that have been taught in an academic environment. We deal with relationships. We're not dealing with physical systems. Most of the quantitative techniques that have been developed, statistics in general, and the other areas that have been worked with, have been based on analyzing physical systems and developing quantitative solutions on how these systems work. Human behavior is different. Water boils at 212 degrees. It doesn't say, I just did that yesterday, I feel like doing something else today. It doesn't say, it's Thursday, I'm tired, I've been here all week. Can I boil at 220 today? I'll make it up on Monday. People's behavior is inconsistent and unreliable and messy and noisy. And when we start dealing with business relationships, we deal with customers, we deal with employees, we deal with suppliers, we deal with all of these different types of business relationships. And I don't have any consistency in the way they behave. The same person will behave differently from one day to the next. A person that looks identical, one person will display a behavior, another person won't. And I need to handle those inconsistencies more effectively. What I really need is to understand the propensities of how people behave. And I have different groups of people who behave differently. I live in Buenos Aires, and there are many things that are done very, very differently in Buenos Aires than they are in the United States. I travel a lot. It's different in Hong Kong than it is in either Buenos Aires or in the US. People behave differently under different circumstances. We don't have the certainty of physical systems. And we need to account for those propensities and merge them when we're dealing in a business environment. In these relationships, we know what our performance is. We're making investments in technology and data and all of these issues to try and enhance performance incrementally. We know that we have relationships relative to the average. Some of our relationships that we deal with are above average. They enhance performance. Other groups hurt our performance. Can we tell the difference between those two groups? In some cases, what we want is a ranking system so that we can adjust the way we treat people based on how they impact our performance metrics. The single easiest way to enhance performance for any business on virtually any problem that's dealing with relationships is to do a better job of spending your time and your money. What is a business? When you think about it, go back to the very basics of every business. A business is a collection of resources. I've got some capital, whether it's financial capital, I've got human capital, I've got time, I've got money. And the purpose of those businesses is to get more time and more money and grow the resources. We do that by delivering products and services. And if I've got different groups of people and I can identify those groups where some of them help and some of them hurt, I can adjust my resource allocation strategies and be more effective. This is the single easiest way of enhancing performance, delivering value with any analytic project that we're working with, is to look at it as a resource allocation problem. Can I spend my next dollar, my next 5 minutes more effectively than I have been in the past? And can I come up with a way of identifying who I should be spending that money and that time on? When we're doing resource allocation, as I said, there's just some people help us, they enhance our performance, others decrease performance. It makes sense. Give more resources to the people that help you and avoid giving resources to the people that hurt your performance. We often work with these quantitative techniques, and regardless of which functional area you're in, are you in IT, in a quantitative support, which perspective you have, the business perspective is the one I want to talk about today. Business people in general aren't as concerned about the mathematical rigor of these formulas. What do they actually want? What serves the business decision maker? That business decision maker, really all they want, they're not concerned with the math. Math is a convenient way of expressing an idea. What I want is some information, some estimate of a future outcome that's going to occur. And I need to make that estimate of a future outcome based on what I know today. Are there a set of conditions that I know today that will allow me to make a better estimate about how people are going to behave tomorrow, next week, next month, next quarter, at some point in the future? And this is all I'm really trying to get. What's this outcome going to be? And if I've got a better estimate of what this outcome looks like, I can do a better job of allocating my resources to enhance my performance, which is what we're trying to do. We use mathematical models. These mathematical models, in a relatively simple conversation, are made up of a set of variables or condition attributes. I have weights that are associated with these condition attributes. These weights do two things. I know that some pieces of information allow me to have what's called a correlation. It tells us that if I know this, I've got a somewhat reliable estimate of a future event. And I can use a weight to give me an adjustment factor on how much influence that condition and changes in that condition have on this outcome. And the other thing that I can do is use it as a ranking system among my various conditions that I have. So I use these weights, these condition attributes, and I multiply them together, and then these variable weight pairs, I give their relationships using mathematical operators. In many cases, it's nothing more than a summation. But it gives me a score. It gives me a propensity for an individual to display some behavior. That behavior can be buying a product, it can be fraud, it can be attrition, it can be all these different types of behaviors that we deal with. But we develop a scoring system that allows us to rate people on their propensity to display this behavior, which allows us to adjust our resource allocation strategies. The people that help us, we give more resources to. The people that are more likely not to display a behavior or to display a behavior that hurts us, we give less resources to. From a business perspective, this is all we're trying to accomplish. How does that impact us? We get caught up in the math, we get caught up in the technology, but we often don't look at exactly what the impact of this kind of an approach has. I develop a formula, I use an algorithm. I don't care what the algorithm is. Anytime I change the set of variables in the algorithm, I get a mathematical model. I can use something like age, gender, marital status, and develop a score of someone's propensity to display this behavior, something like buying our product. That gives us a likelihood. What happens if I use a different formula, a different set of variables? I get a different score. Which one's right? How do we evaluate which one's right? We have to go back and look at our performance metrics for our organization. These programs, these projects are unique and specific to our decision process in our organization because we all have our own ways of measuring success. Some people might be interested in a marketing example at response rate. Other people would be looking at net profit. Still others might be looking at gross sales. Others might just be looking at market share. And I'm going to have a different formula that works best for my performance metrics. My algorithms don't understand my business. They don't understand the problem that we're working on. They don't understand the data. They don't understand our performance metrics. They crunch numbers. Math does not give us a right answer. It gives us a mathematically correct answer. But it's not necessarily the right answer for what we're trying to achieve, because every time I change my performance metrics, I have potentially a different formula that gives me better results. Math gives us consistency, and that's all it does. Every time I change the set of variables, every time I change a weight associated with those variables, every time I change the mathematical operator, I get a different level of performance. So what I'm really doing is a search for a formula that I can use in conjunction with a business strategy that would allow me to go through and enhance performance. If that doesn't quite completely click, take a look at this. I've got my first model that I developed. And I have a second one. With my first model, I go through and I used age, gender, marital status, and it gave me a score for every record that I processed. It gave me a propensity. And when I accumulate those scores across all of my data in my data set, it gives me a level of performance. The second model goes through, uses a different set of variables. It gives me a different level of performance, and that makes sense. If I change the performance metrics, I get the same idea. If I used response rate, I can go through and I can score with the same model all of my records in my data set, and I get a level of performance based on response rate. But if I go through and I change my performance metric to net profit and use the same model, I get a different level of performance based on net profit. I might get 2% on response rate, where I've been getting 1.5% response rate. I get a nice bump in performance, but that same model might actually hurt net profit because I end up mailing to less people to enhance the performance on response rate. Every time I change either the variables in my model, I'll get a different level of performance on the same set of performance metrics. But if I change my performance metrics, I end up needing a different model that gives me a better level of performance. Most of us look at this and say, that makes complete sense. So what? This isn't anything new. And then we rely on our algorithms to go out and give us the right answer. How do algorithms work? I do something as simple as linear regression. And it takes this idea of minimizing the sum of the squared error. And without going into all that conversation, what's error? My model's making a projection of what's going to happen. And in my history, in my data file, I know what actually occurred, and the difference between my estimate and what I projected is error. All of the algorithms use this internal analytic metric that's based on error, with the idea that if I can reduce the error between what I'm predicting and what I'm trying to actually do, I get better results. Show of hands, how many of you in the room get a raise, bonus, or promotion based on minimizing sum of squared error? Doesn't work. Logistic regression uses a different formula. It maximizes likelihood. And we know every time we run different algorithms, we get different formulas. Maximizing likelihood is different than minimizing sum of squared error. Our algorithms even acknowledge that when I have different performance metrics, I get a different formula that optimizes my performance. And none of us get raises, bonuses, or promotions based on minimizing sum of squared error, maximizing likelihood, R-squared lift, or any of these analytic metrics. And unfortunately, when we do this quantitative work, none of us actually go out and develop these models on our true performance metrics that are custom to what we're trying to achieve, and it causes the single leading cause of failure in our projects is developing very sophisticated, elegant solutions for the wrong problem. We've got the wrong set of performance metrics that we're maximizing. Every time I change my model, every time I change my set of variables, I get a different set of outcomes, at a different level of performance. Every time I change my performance metrics, I end up with a different model that gives me better results. The single biggest problem we have is this idea that we don't take the time to go through and understand the business and involve our business decision makers and getting clarity in exactly what we're trying to do, how we measure success, understanding how to set the problem up the right way, because I can't tell the difference between these formulas and what works well and what doesn't work well, except in the context of my specific performance metrics on these projects. Math gives us consistent, and my apologies, I went the wrong way through here. The biggest problem we have is we develop these projects based on our analytic metrics, when what we're really interested in are our business metrics. 30 years ago, the world was changed dramatically with the introduction of spreadsheets. We've spent a generation going through building spreadsheets by taking a set of data, generating reports off of that data, and then putting an assumptions block, and typically in the upper left-hand corner of the spreadsheet, with this idea that I can vary the assumptions, have all of my calculations automatically redone, and see what the impact is on my performance. And these are set up and these are specialized. We've been doing this work forever. This is what-if thinking. We've been doing this for a long time. What are we doing with analytics, with predictive analytics, with big data analytics, with all of these projects that we're working with? When we apply stats, what are we really trying to do? We're trying to find a set of assumptions that maximize our performance metrics. Why can't we just take and add another block that illustrate our performance metrics and have some piece of software that's been developed, and we tell it, maximize the performance metrics by changing the assumptions? This is what we'd like our software to do. Our business users know how to do this. They understand what the data is. They're building spreadsheets all the time. They're doing these reports. They know how to vary assumptions. They know what their performance metrics are. But we take them into these super sophisticated worlds of technology that intimidate them with advanced math and with these large data infrastructures that they don't really understand well. And too many people like me are out here who understand how to use this technology, and in some cases, we're not very good at talking to the business managers and including them in the projects, and we develop very good solutions for the wrong problem. I'm not as good at any particular domain as the domain expert inside of that organization, and I never will be. And the domain expert is sitting there doing their what-if analysis and creating this fantasy environment on what the assumptions are that work best, and then tries to get the world to conform to this environment that the spreadsheet says things should look like. I think it's time that we stop asking what if and start asking who's next. Who should be buying our product? Who should we be auditing in a fraud detection program? Who should we be allocating more resources to? Who should I be talking to next? Where's the best place to spend my next dollar, my next 5 minutes, rather than trying to change the world to conform to the assumptions we think would give us the best value for our organization? When we do this work academically, we're exceptionally good at slicing and dicing our data. We develop these algorithms that go through and they manipulate the data. We start a project. The first thing we want to do is get our hands on the data and start playing with it. Again, show of hands, do any of you get the urge occasionally to go out in your garage and take a pile of lumber and your power saw and just start cutting things up? This is what we do with our data far too often. We don't know what we're building. We've got materials there and we've got these tools, let's cut some things up and see how it works. We have to put it in the context of our performance metrics. A project that I did not too long ago, dealing with fraud detection. I'm not really finding fraud, I'm finding errors. I'm working with an audit manager. He's got a staff of auditors. There's 10 auditors. They want to find errors in payments that have been made so that they can get their money back. And this is how he described, he's got a lot of data, I understood the behavior, I can do resource allocation, I know what the performance metrics are, it's based on dollars, I've got this scarce resource of auditor time, how do I spend it more effectively? This is what he wanted to do. And he gave me this set of data, and I went through, and as you see in the blue column, I said, there's people who owe us money, I make them a 1. There's people that were errors in payments, I make them a 1. Everybody where the payment was correct, I made a 0. And now what I want to do is I want to use these mathematical techniques to help me tell the difference between the 1s and the 0s. Because that's all my algorithms can really do, is tell me the difference between the 1s and the 0s. They don't understand that this is an auditing problem or what we're trying to achieve. But I run this algorithm and I go through this training, testing, validation cycle, and my model seems to be working well on my historical data. And I give it to my audit manager, and he takes his staff of 10 and starts sending them out into the field to do their audits based on people who were selected off of this mathematical model. And 3 months later, he's back in my office. And just walking in the door, I'm really pretty sure he's not very happy with me, just by his tone of voice. And instead of saying hello, he says, "Tony, you're an idiot." That was kind of a giveaway that he wasn't real happy. I'm saying, okay, you're not happy. What's wrong? What's going on? He said, your model is terrible. I said, what's wrong with it? I said, I did exactly what you told me to do. I found the errors. He said, I'm sending my auditors out. Half the time, they come back and they tell me that we owe them money. I don't want to find people that we owe money to. I only want to find the people that owe us money. I'm saying, okay, you didn't tell me that. You told me to find the errors. And that's what I did, with the way I coded my 1s and 0s for my algorithms to learn from. He's saying, that's not what I want. I need it to only find people who owe us money. Can you fix it? I said, yeah, I can fix that. What do we have to do to fix that? We change our pattern of 1s and 0s that our algorithms are learning from. And now what I've got is a different set. My 1s are I changed my definition of who's a 1. I've changed the behavior that I'm looking for. Now my 1s represent people who owe us money, and the 0s represent people where we actually made the correct payment or we owe money to. That's not what I want to find. I don't want to find those people. I want to find the behavior where people owe us money. My algorithms say, okay, this is just a different pattern of 1s and 0s, and I've got a different formula that goes through and identifies the 1s appropriately, and I go through the train test validation cycle, and I build my model, and it validates, and I give it back to the audit manager, and I said, I fixed it. It's not a big deal. It took me a couple days' work to go through this whole cycle. He said, you're sure it's going to work? We're not going to have this problem where I send my auditors out and they find people that we owe money to. I said, yeah, I'm comfortable with that. Occasionally you might get it. My models aren't perfect. He said, okay. Takes it out, he uses it, I don't hear anything from him. 3 months later, he comes back in my office and he's got this look on his face. He said, you know what, you're really not an idiot. You're just stupid. I said, what? Now what did we do? He said, I send my guys out for 2 weeks. I fly them anywhere in the world to do these audits. I annoy my clients in doing these audits. I spend all this money and all their time, and I don't have that many people. Now I've got these guys coming. You're right. We don't owe people money. We fixed that problem. But they're coming back with $1.23. I don't want to audit anybody that owes us less than $10,000. I can do that. You didn't tell me that. You said find people that owe us money. My algorithms don't know how to fix that. I have to put it into my pattern of 1s and 0s that the algorithms learn from. And I can fix it. Now my definition of who's a 1 is only those people historically who have owed us more than $10,000. If you owe us $9,999, you become a 0. If the payments are right, you're a 0. Anything that is owed or people we owe money to are a 0. Only people that owe us $10,000 or more are a 1. My algorithms don't understand that I made a change. They don't know if this is the same problem, a different problem. But this comes back to the idea, if I don't get this pattern of 1s and 0s for the algorithms to learn from correct, I end up developing very elegant, very sophisticated solutions for the wrong problem, and I don't deliver business value. And the biggest problem we have is the only people that know how to code this are our domain experts, and we don't include them in the projects. And they don't understand the math because we intimidate them with things like logistic regression and neural networks and chaos theory and all of these other things that we're doing in this advanced math. Understand that there are a whole group of our domain experts who still get this little twitch when they hear the word statistics because they didn't have a great experience their sophomore year in college in the stats class. But we have to include them because as analysts, we don't understand the domains well enough to set up this pattern of ones and zeros. I do a lot of this work in Excel. Not because Excel is a great analytics tool, but because it doesn't scare my domain experts. They're comfortable in this environment as a communications tool, and they can give me what I truly need, and we've got a common language that we can talk about on how to set this problem up. I'm not worried about the condition attributes and the algorithms and all of these types of things. I need a study guide that's appropriate and correct for what I'm trying to develop for my algorithms to work from. And without that, we lose every time, and this is why for 50 years we haven't been delivering value to our organizations because we don't take the time to get our outcomes and what we're trying to learn set up appropriately for our business users. We try to fix the problems with math and more advanced technology and more esoteric mathematics and more data, and it's not going to fix this problem if we don't have the study guide set up the right way. Finally, we get an approach that tells us the right definition for our audit manager. He only wants to send people out to do audits on clients that owe us $10,000 or more. Now I get a model that actually works well for him because it meets the business need. How do these models actually work? Now we can start looking at our condition attributes, what a statistician would call an independent variable. I prefer the condition attribute terminology because I'm not assuming that they're mathematically independent of each other. Very simple problem. I'm working with a marketing department and saying we can do some of this math that we've been good at, and in fact you've probably been thinking about it this way for years. I'm talking with a small group of domain experts and I'm saying, who buys your product more? And I have one person in the project team that says, you know what, I think gender is important. Men buy at a different rate than women. And we can confirm that empirically, and we take a look at it, and I find that, yeah, he's right. I get a response rate of 1.1% from women, and I only get a 0.87% from men on my response rate. How would we use that? I'm going to send all of my mailings only to women until I run out of women because I get a higher propensity to display the behavior that helps my performance. And I've got somebody else on the project team that looks at it and says, I think it's on age. People who are over 25 tend not to like my product. People who are 25 and under like my product at a higher rate. And I can see that that's accurate too. I go back and empirically test it, and I find that I get a 1.04% response rate on people that are 25 and under, and I get a 0.93 on people that are over 25. Can I run those together? Absolutely I can. And I get this response rate that comes back that's a joint probability, except it's not a true probability when I'm dealing with behavior. But I can do a ranking system now that allows me to go through and say, what I should be starting with are these people that have the highest response rate until I run out of them, then go to the next group and the next group. It's simple. It's not hard. The question is, and the real issue we have is in today's environment, I'm not worried about big data. I'm not worried about how many records I have. I'm worried about fat data, how many fields I have. It's an issue as an analyst to go through. It's easy to do with only 2 variables in my model. How do I do this in 57-dimensional space? If I were to do this in 3-dimensional space, I've got something the equivalent of a Rubik's Cube, and it works very well. Every cell in that matrix has its own propensity to display the behavior. I can do the same kind of a ranking. I asked earlier, how many of you dream in calculus? I don't know how to deal with 57-dimensional space. And I've got some missing data when I start building the complexity of these models out that I have to interpolate into unknown spaces. How do I get into these advanced? I've got a number of models that have 2, 3, 4, 500 variables in my model. They're doing the same thing. Every cell in these 57-dimensional models have their own propensities, and I can adjust my resource allocation strategies, but this is what I need the math for, to handle the interpolation problem into unknown spaces, and how to deal with these highly complex problems that have multiple variables. But the basic principle is no different than using gender and marital status. We know that our performance metrics have an impact. This is a somewhat sanitized version of a real set of performance metrics for one of my clients. I often have conflicting sets of performance metrics that I've got to build these models inside of. And I need the help of math to deal with all the interaction effects. A lot of you are dealing with dashboard technology in the BI environment. Are any of you dealing with predictive dashboards? Show of hands, anybody? Cool, couple. There's no reason that we have to use dashboard technologies as a form of a report. We can use these predictive models to drive our dashboards and allow our domain experts to go through and understand the complexities in these complex sets of KPIs and performance metrics more effectively and evaluate how the models are going to perform and simplify the process so that they're not looking at raw math and large fields of data. We deal with a lot of data. How much data do we really need to do this kind of work? Big data gives us this promise that we can manipulate more data. What I found is, think about political surveys and public opinion surveys. How much data do we actually need? I don't know why we have elections anymore. Interview 2,500 people and find out who's going to be president. We do it all the time, but it's always reported with a margin of error. We can do the same kind of work with our data. I know when I start doing this work, the first 500 or so records gives me very large enhancements in my margin of error. I go from 7% roughly with just a small sample size. I get up around 500, and my margin of error has started to drop already from 7% up to about 4%. I get out to around 2,000 records, and I'm down to a plus and minus 2% margin of error. At that point, more data really doesn't help us that much. I double that and get out to 4,000 records, and I've gone from roughly 2% to about 1.5%. Most of my projects in predictive analytics only use about 5,000 records because going beyond that level, I need absolutely huge amounts of data to have any significant impact, and my models are never going to be perfect. What kind of projects are appropriate? One of my biggest concerns, and has been for a long time, is the hype associated with these technologies. Predictive analytics is a very powerful tool when it's used well. In other cases, it's just not appropriate. This isn't about making our environment fit the tool. It's about picking the right tools to help us solve business problems. Predictive analytics works well when I've got a true business objective, when I've got a set of performance metrics to evaluate performance, when I have a behavior that impacts my performance metrics, because that's what we're really building the mathematical models of, is who's more or less likely to display this behavior, so that I can adjust my resource allocation strategy on this set of scarce resources, and I need enough data to be able to build these mathematical models. If you are missing any of these criteria, you don't have a predictive analytics project. That's fine. Use a different technology to solve your problem. Match your techniques and your tools to what you're actually trying to achieve. Project teams. I'm a firm believer in a project team. I need a project sponsor, a domain expert, end user input. I need someone with the IT perspective from my organization on these projects, and I need someone with some quantitative background. I simply don't believe in the idea that we can take an 18-year-old kid and in 4 or 5 years make them a data scientist who's an expert in all of these areas at levels that are equivalent to the individuals that we have in our organizations. We need data science teams. We need a project team that has the true expertise that comes together and figures out a business solution that actually delivers value. When we work through the development cycle, we go through with planning the project. If you've ever built a house, nobody goes out and just buys a shovel and starts digging a hole. But we tend to do that with our data projects. We just start digging into the data when we're not really sure what we're trying to do. I need the input from my business unit. We then go through and do our data preparation work. We build our models. We confirm that they're going to work with a validation study. And then we go through the adoption cycle, making sure it works, training people, and we cover all 3 perspectives on how it's going to work, and then we look at a replacement cycle. These should be short projects. They should be agile in today's terminology. My projects today are 2 and 3 days, not 3 months, 6 months a year. We need 2 3-day projects because our environment shifts. And we need a complete project team that fully incorporates the business users. We need to start asking who's next rather than what if on these projects and have a methodology that actually works well. We start with our basic formula. We end up going through an incremental development project. We don't have to have comprehensive projects. We start potentially with our positive input tail, then our negative input tail. I know I can do these one at a time. I don't have to solve the complete problem. Can I find one chunk that I deliver a value on? Can I go through then and start looking and combining these models more effectively? Then can I do more advanced work and start to rank across the continuum instead of doing one tail or the other? I apologize. That slide didn't look like that on my computer. Okay? But I can incrementally develop these projects over time, deliver value in shorter time, lower cost, lower risk, get better acceptability because my business users are involved in the development cycle. They see it every step of the way. They're involved in the design. I've got redesign points as I go through. I go through the full training, test, validation cycle. And training, I build these formulas. I test them. I validate them. I validate in the confirm stage. I need to do the data preparation work first based on the plan that I've developed. I walk through the prepare, build, confirm. I move into adoption and then go into a replacement phase and have this consistent 6-phase development methodology. And this kind of an approach is very simple. And this is the kind of thing that we can work with our business decision makers on and have a methodology so that we can put predictive analytics on the desktop of everybody who owns Excel so that they show us what we're really trying to do and how we can assist them in an environment and in a language that makes sense to them without overwhelming them with technology and math. Right? We're dealing with these business relationships. We have to handle all 3 perspectives. We have to deal with the quantitative issues. We have to deal with the data issues. But we also need to understand that we're here to support the business and deliver value, deliver return on investment. This is the way I would like to have you consider at least thinking about these analytics projects and not getting caught up in the technology and not getting caught up in the IT. We do this work to support the business units and our business decision makers to deliver value. That's our challenge, and the problem is we've been trying to figure it out for 50 years, and if we're not successful with it soon, we're going to start losing funding because they're getting annoyed with us. We bought this software over and over again. We keep building new architectures. We need to consistently, reliably, incrementally enhance the business performance. Thank you very much for your time, your attention. Enjoy the rest of the week. Have a good day.